Hi everyone, welcome to another episode of my tutorials on Circos for bioinformatics. In today's video, I'm going to show you how to generate this cool Circos plot here. This is a plot showing the genome assembly coverage of a bacterial isolate. Right, so the outputs here, okay, we have the outer circle and we have the inner circle. The outer circle is the ideogram, and in this tutorial, it's used to represent the contigs. All right. I repeat, the outer circle, the circle with the different colors, it's representing the contigs. We have the labels also here. So we have contig 1 to 50. That's what we have here. The inner circle represents the coverage. All right. So let me just put this. It's represent the number of reads that's marked to each of the contigs. That's what it represents. And so here we can see that contig 1, the number of reads that's mapped to contig 1, okay, is higher than all the other contigs. All right. Now it's important for you to understand or know how I got the input file or the information for this plot. So I will switch to this folder here to explain a couple of things. Let me just go back here. By the way, this is where we can get example data. So we'll come back to this. Let's go back to this one. It's important for you to understand. So first of all, I got my FASTQ data for the isolate. So the isolate here is Mycobacterium mostrans. Let me just put it this way. The data here is from a Mycobacterium isolate. All right, so this is it's a paired data. I then perform de novo assembly using spades. All right. By the way, for beginners, I have a tutorial that shows how to perform genome assembly using spades if you have paired data like this. So the link to that video is in the description box. Now let's continue. So I perform genome assembly using spades and I got my contigs, which are all saved in this file here. And then I map the reads, the FASTQ reads, to the contigs. That's what I did. So I use BWA. And then I converted the output to a BAM file, which is this one here. Right. So this BAM file here, I put it there, and then I looked at the contigs again. I looked at the length for all the contigs, and then I took the top 50 longest contigs. And then after taking the top 50 longest contigs, I looked at their mapping information in the BAM file. Okay, and I got my coverage information. All right, so this is how I got that information, which is here, okay, the coverage.txt. Right, so let us look at this file before we proceed. Okay, but let's just say that it is from this file that I now got this Circos plot here. All right, so it's that simple. If you know the steps, then you can always get or reproduce the plot here. All right, so for those who want to generate a similar plot, you can always reach out to me and we can have a session. I'll show you how to also do that. So that's what we are going to do today. And let me say that if you want to follow this tutorial, you need to make sure you have Circos installed. For this tutorial, we are going to use the command line version. Okay. But if you don't have Circos installed, don't worry. In the next episode, I'll make a tutorial that shows how to run Circos on Galaxy to generate this same data. All right, so if you don't have Circos installed, don't worry. Just make sure to follow and understand the steps. And then in the next episode, you can use your browser to generate this plot. So let's continue. So let's do this. We need to get the example data, or let's say the input files. And so we will need to go to GitHub. I have the data here. So there's the page. I'll leave the link to this page in the description box. All right, so we need these files, coverage.txt and karyotype.txt. So these are the files we need. I repeat, the link to this repo is in the description box. If you want to download, click any of them, and then you'll be sent to another page and you can download it. Let's just do this. Okay, so click, and when you click, you'll be sent to this page, and you can come to the download button here to download, or you can also click on raw. And when you click on raw, you get something like this. You can right click and then go to save pages. This will also save the file for you. So the same step and we apply to this one here, the character.txt, and then you download that. So we have two files. Now the content was fast A. All right, so this is here for reference purposes. We are not going to use that. So if you want to download it, fine, but we are not really going to use that. So that's why I am not making mention of it here. So these are the two main files. So get them, and then you have them on your PC like this. Okay. So before we start the exercise, let's look at them. So this is the coverage.txt. So this is how it's going to be if you open it with your text editor. So I have the contigs represented with the labels here, OS 1 to 50. Also have the length, the contigs basically. And the number here represents the number of reads that's mapped to that's contig. Okay, for example, there's OS 1, that's contig 1. We have 24,694 reads mapping to that contig. We also have the others here. Okay, so that's it. Now we also need to get the karyotype, which is here. Okay, so this is a character. So this also has information. So you can even say that the karyotype is what you need first, and then we add a plot to so that we have a beautiful visualization. So this one is used to depict the contigs. That's the outer circle. This one, let me just do this. So the outer circle here, okay, that is what we use this information to generate. Okay, so this information is also very, very important. So you should always make sure you have that as well. So take note of that. So these are the two input files. Now we are going to write some commands to generate the plots. So the commands are here, this and then this. All right, I will do this in an interactive manner. I repeat, I'm going to write the codes in an interactive manner and explain a couple of things. All right, but for those who want the complete codes, you can still check the description box. You'll find the link to download these two files. Okay, conf and an ideogram. I repeat, the link to download these two files are in the description box. You can find them on my Patreon channel. Okay, so let's proceed. So these are the two main input files. So we are good to go. So let's continue. So let's do this. So what we'll do first is to generate the ideogram. All right, we need to generate that one first. Let's go back. So we will generate this one first, and then after that we will add a coverage to it. So the coverage, that one we get it using the coverage.txt. All right, so take note of that. So let's get back, and then let's open a text file. Now these are normal text files, so you can use your text editor, but I would prefer to use the command line. So that's what I will do because that one is comparatively faster for me. All right, so I will open my terminal now. I will start. Okay, what I'm going to do now is to generate the ideogram. All right, from the character file. That's what we are going to do here. All right, so let's start. If you are not comfortable with the command line, that's fine. You can also use the text editor of choice. So let's do that. So I'll do this first. Let me just enlarge it here. I'll say nano ideogram.conf. All right, like this. And then I'm going to put in the commands to generate the ideogram. So basically, the ideogram contains information that will be used to generate the ideogram. Okay, I repeat, the ideogram.conf file, okay, contains information that will be used to generate the ideogram. So it's important that you follow what I'm doing and then try to do same. Okay, if you're a beginner, don't worry, try to follow and then make sure you get the exact steps, and then you can go back to Circos and then just check the documentation. All right, I will leave some useful links in the description box for you to also proceed or read on. Okay, so let's do this first. Let's first open our block. I'll say ideogram. and then I'll close it with this one, Histogram, like this. I have that block. Okay, that's very, very important. Then after that, I'll put another block here for spacing. Then I'll close it like this. Okay, so that's this. Then in the spacing, I'll put in some information. And please take that I'll try my best to explain the instructions, and some of them, they are rules that I have to follow. So if you want more details on them, you can visit the Circos documentation page. Okay, so let's start with the space, and I'll define some default values. I'll say default equals 0u, no spacing between the ideograms, or in this case contigs. Break equals 0u, nothing. That's for the spacing. Now I've already closed that block, so it's fine. Let me just do this way. I've closed that block, so this is fine. Okay, now let's move on to another one, which is thickness. Thickness, I'll say 20p, but you can always change this value, all right, depending on how you want it to be. So some of them are for formatting purposes, so you decide based on the outputs whether that value will maintain or change. That one, it's up to you. We also have stroke thickness. Let me just correct it here. So stroke underscore thickness equals 2. And then I'll define something else, which is ideogram border color. Then I'll say stroke color equals black. Say fill equals yes. So the fill equals yes will allow us to use the colors, right? You notice that with the karyotype, I have some colors also here. All right, I have the description of the contigs, and then there's a column for color. So it is this here that will be used to give colors to the respective contigs. All right, so that is what we are indicating here. Okay, so fill equals yes. You can also give a default color as well. So the default color is there, but then what you should notice that the colors defined in the karyotype supersedes, okay, the default color settings. So you need to take note of that. Okay, so I'll actually leave the default color out because we have already defined the colors. So that's it. Now let's look at something that's fractional radius position of chromosome. Okay, that's what we have, chromosome ideogram or ideogram. Then I'll say radius equals 0.85. Now let's add the r. Okay, so I have radius equals 0.85 r. Okay, the value here is not fixed. This can also be changed or manipulated depending on how you want the outputs to be. So what you should note is that some of the values are experimental in the sense that you first have to start with those values, take a look at the plots, and then you can modify them as you see fit. Okay, so take note of that. Now let's add this. Let's say show underscore label was yes, we want to see the labels. You know, we had 1 to 50, so we want to see that. Okay, so I have that also here. And then I also have this. Let's add it. So label fonts equals default, to use the default font. Then label underscore radius equals, I'll say dims ideogram radius plus 0.05 r. That's what we have here. This way. Now with this value, I got it from one of the Circos tutorial, so it's worked for me. That's why I also use it. Some of them, there are rules you have to follow, so I don't really bother to look at the actual functions because I just want to get my plot done. But if you want more details on them, you can check the Circos documentation page. I'll leave the link to that page in the description box. All right, so take note of that. Now let's do this. Let's add label size, let's say 40. This value can also be changed. And then label underscore power equals yes. So this will help us to properly position the labels, right? And then let's say label case equals upper. Okay, now this particular one, I don't really need to specify it because my labels are numbers, but I just thought I'll bring it here because some of you want to use a different label which will include alphabets. All right, so in that case you can decide whether you want the labels to be uppercase or not, so you can use this option to do that. All right, so this is for the ideogram configuration. So let's just make sure it's close. I think we had it here, so I'll just bring the, yeah, so that's fine. Just need to make sure that I have everything we need. Okay. So I have everything I need here, so it's important. Just try to follow the get everything done, right, like this. Okay. So this is the configuration for the ideogram or ideogram. So I'll save it. I'll do an ls. I'm going to find it there. So ideogram.conf. That's what I have here. So I can also see it here. It has been created, and that is it. You can also use a text editor to create it and then save it. But make sure they are all in the same directory. It's very, very important. So I have that done. So this information is here. You need it. Okay. So now we need to also look at the conf file, the configuration file, which has the master information. All right. So that's what I'll do. I'll open another terminal and then I'll start. Well, I could have also used the old one, but that's fine. I'll just proceed with this one. So I'll do an ls again. I see my files coverage ideogram character with tst. Now I need to also look at the configuration file. Okay, so that's what I'm going to do. I'm going to say nano conf.txt. You can also say circos.conf. That one depends on, then name depends on you. So I wouldn't go into details. So this is going to be the configuration file. So I'll start with this one, include ideogram.conf. And I'll close it like this. And I'll say karyotype equals karyotype.txt. And then I'll define chromosome units equals 10,000. I'll define it like this. Then chromosomes display default equals yes. I'll also put it like this. And then I also have this. I'll just say image. This is also a block. All right, it's also a block. And then in that block, I'll say include image.conf. Okay, so there's it. And then I'm going to add something else. Okay, those files are also for formatting purposes. It's important to include them. They are compulsory. So I'll add them also here. So I have this include, and I'll say housekeeping.conf. I also have include colors, fonts, patterns.conf. This also needs to be included. You should also make sure that the spellings are all correct. All right. So you should have something like this to begin with. Okay, so This is going to be our starting point. Let's just make sure we have everything. Okay, so that is fine. So we can proceed. So I'll do this. I'll edit and save changes. I'll do an ls. I'm going to find my convert.txt also here. So I am now ready. Okay, I'll clear the screen. I'll do an ls again. Perfect. So I have my files. I have my conf.txt, which are the configurations. I have my courier.txt, videogram, character. All right. For this first stage, I did not make reference to the courier.txt because the focus is to just get the videogram and then make sure that everything is okay before I'll add the plots, which is courier.txt. So I'll make reference to the courier.txt later on. For now, let's run Circos. All right, so I'll say Circos -conf and I'll say conf.txt. So let's execute this command. Perfect. So we should have something like this, and then we have to wait for Circos to complete its work, right? So what we need to do is to also monitor, and then that's fine. So now everything is okay. So if I do an ls, I'm going to find some files here, circos.png, circos.svg. All right. So I'll open them here, and there's it. Okay, so now I can open it, this one, and that's it. Okay, so now it looks very nice. So this is the output, this is the ideogram. So we have our contigs, contig 1 to 50. Okay, everything is here. Okay, so it's a very cool plot. There's also the SVG, which is also generated by default. So this one can be edited. So I can do this. So I have two that can edit such files, vector graphics like Inkscape. I can just open that and then maybe do some editing here, right? Like this one here, I can just move it about. Okay, I can even move some of them about. Let me just zoom in here. Okay, I can change some of the stuffs. I can add text. Maybe you want to add some more text, you can do that also here. And change the font size, all those stuff. So this can also be done using the SVG. All right. So it's just to let you know that you can also edit those plots. But for now, I'll just close with that saving because the focus is to just generate the plots. You can do the manipulations or editing later on. Okay, perfect. So now we have the ideogram generator, which is nice. Okay, so what we have to do next is to add the coverage information, which is this one here, right? So to do that, you have to include a plot function, and then we'll specify the type as histogram. So let's do this. Let's go to the Circos page for histograms, which is here. I'll leave the link to this page in the description box. So there are rules you have to follow. Basically, we've done a lot of them. So once you do that, you can now generate your histogram. Okay, so we are going to generate a histogram such as this one here. Okay, histogram, there are different histogram types, but that one you have to read and then decide what you want to do. We are doing the basic one. It's to help you get started, but for complex ones, we will later look at them. Okay, I'll treat them in separate tutorials. For now, just read this page, read the instructions on this page if you want to read more about how to generate histograms. All right, so it's very, very simple once you know the way around it. Of course, the key is to make sure you have the right data, which also requires some knowledge in programming because you'll be dealing with a lot of information and then a lot of formatting. So the key is to get the data in the right format and then you're good to go. All right, so let's get back to our data. So there's the com.txt, which is here. Okay, so I'm going to add something else to it. Okay, but before I do that, I'll make a backup of it. Normally, I make backup if let's say I have a working script or a file which is working, which is okay, and I want to modify. I first make sure I create a backup so that I can always do a reverse, or I can always undo the changes if something goes wrong. So I'll first make a copy of it. I'll not use it just for backup purposes. I'll still modify this one here. All right. So I'll do this. I'll come back here. I'll clear the screen, do an ls, and then I'm going to edit it again. So I'll say nano com.txt. Okay, and I'll edit it. Again, it's a text file, so you can use any text editor. That's also fine. So take note of that. Okay, so I'll do this. I'll come here. These are all okay. Okay, so I'll put the next commands here within this region because these ones are fine. I don't want to risk modifying them, so I'll just put them somewhere here, and then I'll modify this one here. So I'm going to add the plot. So if you want to add a plot, you bring a block. So you have plots, then you have plots. So this is the block function. Okay, that's what you need, and then you can put all your plots there. Please take note there are different plots: scatter, histogram, etc. Okay, so you can put all of them in the plots block. Okay, so I have the block. So each plot you put, you should also have another sub block. And so because we are going to add a histogram, we will say plot. Then I bring this and I bring another one here. Plots. So in this block, I will define the options. I'll give a description of the histogram. So first of all, I'll say this. I'll say file equals coverage.txt, and then I'll say type equals histogram. You need to specify that. And then for radius, I have R0 equals 0.6R. And then for R1, it's also for radius equals 0.95R. All right, this is important. Now with histograms, you can also define minimum and maximum value, but there's something we'll look at in another tutorial. So take note of that. Now let's define the colors. So color equals red, that is what we'll use. Then for color is also red. You need both. And then let's define thickness equals 2. All right, so that is it. That's all that we need for now. Okay, so this is also done. So what we have to do is to make sure that everything here is fine. Then we can proceed. So far, so good. Okay. So I'll edit and save changes, and then I'll proceed. Please take note that when you're running Circos, it will always replace any file which has the same name as the output. So what we are going to do next, we'll replace this one here, these ones here. So if you want to keep the old ones, then you can always make a backup of them. All right, so take note of that. So what I'll do, I'll just do this. I'll just put a copy here. These are ideograms. Okay, I'll just rename them. I think it's better that way. I'll just rename them. You don't need to do this, by the way. I'm just doing it for my own stuffs. Okay, so I'll just put it this way. So I'll come back to Circos and rerun. So now that's what I'm going to do. I'm going to say circos-conf, and I'll say conf.txt. I'm going to run it. So let's execute this command. Perfect. So once you do that, Circos will also start to work, and then to generate the plots. So again, we will have our plot generated. Let's look at this and let's see them there. The output name is all the same. All right, so now we have it here. So we have it's here like this. So this is it. Okay, it's very, very cool. Okay, so this is how we generate the histogram. Now, some will decide to add something else. If you compare this to what we have in the presentation here in the slide, you see we also have these red lines also. So we can also add that to make it visually appealing. So what we are going to do next is to add these lines to it. Okay. And then we are done. So let's look at that. I'll go back to the command line and then I will do the editing. Okay. So let's get back here. I think I'll do that here. Let's see. Let me just go back here. Let's open it. Yeah. So let's get back to the terminal. And then this time we are not going to make any backup. We are still going to modify it here because basically we are adding on to the plot. So I'll say nano home.txt and then I'll scroll down to the plot section, still in the same block. That's what I'm going to do. I'm going to add this to it. Let's look at this. It's still the same plots, okay, the same subplots. So that's what I'm going to do. I'm going to add another option to it. So let's even go to the Circos documentation or configuration. It even shows how to do that. Let's check. So we are going to add what we call axis. So basically, I'm going to add this to that plot. It is what I'm going to add, right? So I'll go back to the terminal and I'll add that here. So that's after the thickness. So I'll do this. I'll just say axis. There's also a block, by the way. So this is the main axis block. And then in it, I'll put my axis. Okay, so I have axis like this. And then I put another block, axis. So you just put it like this. Okay, and then in between, we now put in the information. So color was L gray. It's like this. And then thickness equals 2. And then spacing equals 0.1 R. Again, these numbers, you can always experiment them and then choose the one that you see fit. Okay, so this is it. So I'll just edit and save changes. Okay, but you also need to make sure, let's go back, you need to make sure that you have closed all the blocks. It's important. Okay. You need to make sure you have closed all the blocks so that you don't encounter any challenge. So I'll now edit and save changes. Okay, so now I can run Circos again. So I'll just say circos-conf.txt. So let's execute this command. Perfect. So Circos is now running. Okay, so that has been done. So now when you go back and you open it, you will realize that you have those lines. Okay, also specify. Okay, so these lines are also important because it can also help you to it makes it visually appealing, and it also makes it easy to do the comparison, right? Unlike the previous one. So this one looks fine. And for the thickness, you can also increase it. That one is up to you. So I'll leave that to you to also do that. You should also take note that the interpretation of the plot should be tailored towards what you want to display or the information you want to carry out there. And so with interpretation, it's up to you to decide how you want it to be done or what you want to do. At least for this one, it's representing number of reads that's mapped to contig. So you can do the comparison. Okay, for example, we have this comparison. So here it's obvious based on the visualization that the contig one had the number of reads that's mapped to contig one is higher than all the others. So if let's say you were interested in a particular contig or particular sequence, then This will help you to identify those patterns. All right, so those ones you have to decide how best to represent and interpret your data. Now, this same information here, this same plot can be used to also represent other information. Okay, so it depends on you, by the way. So Circos allows you to generate different plots, and so at the end of the day, you have to properly plan and make sure you know what you are doing. All right, so that's it. So that will be all for this tutorial. And then the next episode, I'm going to show you how to generate the same plot on Galaxy. That's what we do. And I also try to make Circos plot for visualizing ionistic data. It's also something I'm working on. So I'll also update you when that is done. So just make sure to follow this channel if you're new, and then get notified for if there are any other uploads. And again, for those who want to support, so the description box, there are links you can use to buy me a coffee or something like that, and that's fine. You can also get some exclusive tutorials from my Patreon channel, exclusive tutorials, and then scripts that I use for my tutorials. You can find all of them there if you want them as well. So that'll be all for this tutorial, and I'll see you in the next session.